So, okay, guys. Today we're going to talk about what the whole day today is talking about a relation. Okay, what relations are in terms of math. They're actually pretty similar to relations that we have in life. Okay, for instance, you have a relationship, you're related, you have a relationship with your whole family, right? And there's different ways that relationship you relate to your family members. Okay, and there's specific ways. There's specific ways that a parent relates to their child, or a grandchild relates to their grandparent. Okay, the same way is true in terms of math. In terms of math, we're going to relate different values, different groups of values to another group of values. Okay, there's specific ways that we can relate those. There's specific ways that we can represent relations or show how things relate, okay, or visually do it. And that's what we're going to talk about today. Later on, we're going to get into functions, which are very specific types of relationships, okay, between numbers or values. Those, when we get into those represent like equations and things like that. Okay, so specifically, one way to represent a relation is graphically within the Cartesian coordinate system. Something you've already done. You've already done that. One way is to represent it graphically, visually, as a graph, like where the points A, B, C, and D are graphed up above right here. Like where this is a visual representation of this relationship between these X values and these Y values. You with me on that? Okay, a written relationship between these X values and these Y values are represented down here with the ordered pairs. It represents how to get from X, what value of Y we get for each value of X. Okay, so we have represented this relationship, this relation in math, once graphically by this set right here. Okay, by the graph and the Cartesian coordinate grid. We've also represented it by just writing out the numbers in ordered pairs. There's more ways to represent a relation than that. A mapping or a rule to get from an X value in our case to a Y value in our case. Okay, we can represent them by tables. Okay, by a table of values that you've also seen. We could represent it by an ordered pair. We could represent it all by a graph. This is the same way that you can represent your relationship to your family and your family members in different ways. Okay? If I wanted to express my relationship between me and my parents, one way to do that is to stand next to them and have people look at us and see that we're similar. That would be like a visual representation of me and my parents, like my family, would be to find the similarities in what we look like. Okay, that's one way to represent it. Another way to represent our family would be to the fact that we all have the same last names. That's not always the case in families, but in my family, we all have the same last name, Showalter. If we talk about the Showalters, that's another representation of my family, a second version of the same thing. Okay, a third representation of my family could be putting us all in a family tree, okay, and looking at that. There's kind of another visual-ish representation of my family. Okay, a third way to represent, or a fourth way to represent my family would be just to talk about how my parents and I interact. Okay, that's a representation of our relationship, all of which are representing our big, wide-stretching relationship. Okay, but there's different ways to represent that, and each one has its own value. The same true as when we're talking about mathematical relationships. We're going to represent them in four ways we're actually going to talk about today. 4 different ways to represent the same thing. First, we're going to start with the thing that's pretty familiar to you by an ordered pair. One way to represent relationships would be by an ordered pair. Right now, I'm just hypothetically creating some relationship between ordered pairs, okay? So I'm just going to write out some hypothetical numbers. I'm saying this is one way to represent this particular relationship. I'm going to say 0 to 5, 0 to 8. I'm going to say 1 to -2. I'm going to say 3 to -2. I'm going to say -1 to -5, okay? Hypothetically, say that is our relationship or our relation of these values as an ordered pair. Let's now represent that as a graph in the Cartesian coordinate grid. We go ahead and we just drop the points in, and we just plot them. That would be a visual way to represent it. Plot 0, 5, plot 0, 8, plot 1, -2, plot 3, -2, and you can plot -1, -5. Did I? Oop. 0, 5. Sorry, you know what? I plotted these two wrong. Oops. Backtrack. Let's do that again. 0, 5, 0, 8 would be up there. And then 1, -2, 3, -2, and -1, -5 up there. Sorry about that. That right there is a visual way to represent the same relation in math. We can also represent it by an XY table, where we just make a T-chart and we start dropping in the ordered pairs from left to right. The thing that's important to know about a table is the X values have to be in numerical order. Okay, the X values need to be in numerical order in a table. Okay? That's the only thing that's kind of contingent on this. You could go ascending or descending order of X's. It doesn't matter. I just need them in numerical order. So I'm going to go least to greatest just because that's the way I like to do it. Okay? That would be representing it in a table. There's a fourth way to represent this relationship, and that's actually on the next page. Okay? Okay, a fourth way to represent the same situation, the same relation, okay, would be what we call a mapping. It's another kind of visual way to represent how one number maps to the other number. Before we actually do this, I need to define two words for you. I need to define the word domain and the word range. So we're just going to write that up above, right here. Domain the set of input values, or the set of inputs, you could say. The range, the set of outputs or output values, in this case, in most cases. Also, in most cases, the domain is typically the X values, all the X values, and the range is typically the Y values. Okay, it's a listing. It's a listing of all the X values. It's a listing of all the Y values. Okay. Okay. We're going to represent the same exact thing in what we call mapping. A mapping. The things on this, kind of some pointers on this, typical convention. The first thing is that they need to be, numbers need to be in numerical order. Okay, that's one of the pointers. The other pointer is that each number, this one's hard to articulate, each number is only written once in the domain or the range. That is not a specific way to say it. I'm having trouble articulating that. But what I mean by that is don't write the number 2 twice in the domain. Don't write the number 0 twice in the domain, in this case. Don't write the number -2 twice in the range. Does that make sense? Don't double it up. Don't double it up. For instance, in the domain, we're going to write them in numerical order, so the least one being -1, and then it's 0, and then it's 1, and then it's 3. We do not write 0 twice, even though it's represented twice in our ordered pairs. The same thing is true with our range. Numerical order, so -5 is the least, then -2, then 5, then 8. Again, we're not going to write -2 twice in the range, even though it shows up twice or once. Okay, now for the actual mapping part of it. We're going to map, if we look at our ordered pair, we have -1 going to -5. So I'm going to draw an arrow from -1 to -5 to represent that's how they map from one to the next. Okay, based off of that ordered pair right there. Then I'm going to take the next 0. 0 maps to 5, so I'm just going to draw an arrow from 0 to 5, saying 0 maps to 5, or 0 is connected to 5. Then I'm going to represent 0, 8. 0 goes to 8 as well. So there's 2 arrows coming off of 0. 1, -2. 1 goes to -2. Draw an arrow there. And then on our last guy, and we're going to do it in gray, 3, -2. 3 goes to -2. Okay? Again, what the mapping shows, the input values, which are our domain, it says after we put the input values into our rule or our relation, okay, if we put our input values into our rule or our relation, we're saying it goes to which values in our range or our output values, okay? Again, domain, these are our input values, range being our output values. What happens to our input values, the domain, when they map or turn into our output values? Okay, these are our rules. We stick these in, and when we stick those in, we get our range out, or get those out for those particular input values. Okay? It's like on a Coke machine. You press a button for Coke, and you should get a Coke out, right? Your input value on a Coke machine is pressing the button that says Coke. The output value is the actual can, or bottle, or whatever. Okay? Input, output. Okay, what I want you guys to do as a group is I want you guys, as your study team, I want you to represent it as a table, a graph, and a mapping from an ordered pair. And go as your study tables, and then come to a collective decision, of course, and let me know if your whole study table needs some help on it. Oh, okay, when you do it in a table, remember, X, Y table, your X's go in numerical order, so -1, 3, 7, 9. Ascending or descending, I don't care. Your Y's, it doesn't matter, except for the fact that they need to match with the corresponding X. Okay? Next, your graph, you guys are pretty fluent on that, which is fantastic. You guys were doing a great job on that. Okay, that's your map, that's your graph. Your mapping, remember your X's need to go in numerical order. Ascending, descending, I don't care, as long as both match. If you choose to do descending order on the domain, do descending order on the range. If you do ascending order on the domain, do ascending order on the range.
I don't get what you're saying, Mr. Short.
Ascending is going from lowest to greatest. Descending is going from greatest to least. And then again, do not repeat the same value in the domain or within the domain or within the range. Write domain or range over the top, or a D and an R. Also, do the mapping, so you draw the arrows. Please make sure they're arrows. Why? Because that's the way I like it. Okay? We feeling good about that? What I want you to do, we're going to reverse it again. We're going to give you something else to start from. Okay? We're going to give you a new thing that we're starting from. Oh, first, hold on, one more thing that we need to do. You guys don't have this written on there because I added it after I printed it. But we're going to just specify what the domain is. We're just going to write it out separately. So write down underneath your thing, write domain, and we're going to list the domain values there. It's just, when I ask you for the domain, I'm just asking you straight for the listing. So like -1, 3, 7, 9. That would represent your domain. It's just a listing of the numbers. The same thing, do not repeat the same number twice in your listing. Range, 2, 4, 7. Write them down. All right. Now what I want you to do with your study teams is I want you to answer these two questions, these two examples. Okay. On the second one, there's not one specific answer. There's multiple answers for the second version. You just need to make sure you qualify for the constraints that you're given. Make sure you hit all the domains. Make sure you hit all the ranges. Oh, okay. I'm asking you to write the ordered pairs from the mapping. Okay. First, ordered pairs are two numbers separated by a comma and within parentheses. If you do not write the parentheses, you just listed two numbers. It's not an ordered pair. That means it's totally wrong. Okay? For instance, you need to write it specifically with the parentheses, 1, 2 with parentheses. If you do not write it with parentheses, that's like writing a sentence without a capital or a period. That's without capitals or punctuation. Okay? You have to have the parentheses in there. If you don't, you're going to get marked off because it's wrong. It's not proper math. It's not proper grammar. It's not proper math. Okay? 1 goes to 2, 1 goes to 6, 3 goes to 2, and 8 goes to 5. Okay, let's do it again for the next one. The next one is write the ordered pair given the domain and range. Here's one that there's no specific answer. There are characteristics of a specific answer, but nothing specific. What you do need to do is you need to make sure that all your range values are represented and all your domain, all your domain values are represented and all your range values. So when I write this, I need to make sure I have a 1, 2, and a 5 in all of my domain. Okay? I also need to make sure that 3 and 6 are represented in my range values or my y's. So I could do this if I wanted. That works. Not with a giant parenthesis, though. That's awkward. Just with 3 little parentheses. A second representation of that, you could have 1, 6, 2, 3, 5, 6. You could have all 6 of those if you wanted. You don't have to have 6. You only need 3. But what you do need to do is you need to make sure all those domain values are represented and all the y values are represented, or the range values. Okay? Again, if you're having trouble understanding this, check out the video when you get home.